Hi students, now I am going to teach a topic of permanent magnet moving coil. It is named as PMMC. So let's start the topic. So it is called as a PMMC, permanent magnet moving coil, or moving coil, or de-Arsenal movement. Why it is called as de-Arsenal movement means because this particular scientist gave this movement. So what? So it has a this particular arrow mark is of a pivot and jewel bearing. This is of aluminium frame. So this red color is of a copper coil. And there's a flat spherical springs. This center spring is of a spindle. So what is our logic behind it? Whenever a current carrying coil is placed in a magnetic field, it experiences some force or torque. I'm repeating again. Whenever a current carrying coil is placed in a magnetic field, it experiences some torque. So what is this? Is of a deflecting torque, and this is controlling torque. This is my scale and pointer mechanism. This is scale and pointer mechanism. This is scale and pointer mechanism. This scale and pointer mechanism. The flat spherical springs. So spindle. So whenever spindle starts rotating, so my pointer will show some deflection. This is a basic principle lies behind it. So whenever a current carrying conductor is placed in a magnetic field, it experiences some particular torque. So let's come for constructional details. Here spindle is under the force of jewel bearing. Here spindle is under the force of jewel bearing. So please see here bearings are there now. So these are all called as my bearings. These are all called as my bearings. Then next, at the center of both spindle and permanent magnet, an aluminium frame is placed. This is wounded by copper coil. So this is called as my aluminium frame. This is called as my aluminium frame. So it is wounded by copper coil. This red wire is called as a copper coil. This red wire is called as a copper coil. Then next, pointer made with steel. Pointer made with steel. So spindle made with aluminium. Sorry, pointer is made with aluminium. Pointer is made with aluminium. Spindle with steel. Spindle with steel. Okay, na? Jewel bearings to reduce frictional errors. Jewel bearings to reduce frictional errors. Then next, what is friction? Because there are bearings now, bearings will have some friction. So that is called. Then next come for Lorentz force equation. What is Lorentz force equation? Whenever a current carrying conductor is placed in a magnetic field, whenever a current carrying conductor is placed in a magnetic field, it experiences torque. F is equal to BIL sin alpha. F is equal to BIL sin alpha, where alpha is the angle between plane of coil and permanent magnetic field. Since it is a radial magnetic field, so alpha is equal to 90. Means you will get both perpendicular. So alpha is equal to 90. Then next, what is torque here? Torque is equal to force into perpendicular distance now. Torque is equal to force into perpendicular distance. So deflecting torque So deflecting torque is equal to deflecting torque TD, T small d is equal to force into perpendicular distance, force into perpendicular distance. So TD is equal to, for what is the force? BIL. Earlier we have shown what is force formula? Force is equal to BIL sine alpha. We have we saw it earlier. Lorentz force equation. BIL into what is the perpendicular distance? D. This is the perpendicular distance D. So this becomes TD is equal to BIL into D into N. What is N? Is of a number of turns. First of all, what is this coil and all? Let's see in this diagram. So I will have one copper aluminum frame. Now I have this aluminum frame. This is wounded by copper coil. So if I take this as a D, and I will make this as a D by 2, and this is the length. So what is my torque here? Torque is equal to force into perpendicular distance. Torque is equal to force into perpendicular distance. So what is the torque per conductor? Torque, deflecting torque per conductor. How per conductor is equal to BIL D by 2, because force into perpendicular distance is of D by 2 now. Perpendicular distance is of D by 2 plus BIL D by 2. This gives rise to what here? So again, how many conductors will make one turn? One turn is equal to 2 conductors. That one turn is equal to 2 conductors. Then next, your TD per turn is equal to BILD, and TD per coil is equal to BILD into N is equal to TD per coil is equal to BINA. So A is equal to L into D. So this is very, very important. BINA is very, very important formula. Then next, TD directly proportional to I. So it's a current sensing instrument. It's a current sensing instrument. What is N? Number of copper coil turns. Number of copper coil turns. B, flux density. A, area of copper coil. Area of a copper coil. I is current through copper coil. So then next, Spring mechanism is used. Spring mechanism is used to produce controlling torque. Spring mechanism is used to produce controlling torque. Tc equal to Kc theta. What is T? Kc is spring constant, theta is deflection angle. What is theta is? Deflection angle. So Tc equal to Td at final steady state position. At final steady state position, Tc equal to Td, Kc theta is equal to Bina. So then next theta is equal to 1 by Kc Bina. So then next theta directly proportional to I means what? Your deflection angle. So it is a linear relation. It is a linear relation. The next, in case of voltage measurement, in case of voltage measurement, in case of voltage measurement, theta directly proportional to I directly proportional to V. So finally theta directly proportional to V. So the next in motor principle is what? In motor what we use? Fleming's left hand rule. Fleming's left hand rule. We use Fleming's left hand rule. Whereas in generator, we use Fleming's right hand rule. Fleming's right hand rule. So very, very important. How to remember this? Please try to understand here. Here R, here R. Whereas in generator, 2 R's. So the next, in PMMC, flat spherical springs are used. In PMMC, flat spherical springs are used, which carries current into and out of the coil. Then next, if top spring or bottom spring snapped. Snapped means broken. No current enter into coil. No current enter into coil. Then meter indicates. Then meter indicates 0. Then indicates meter indicates 0. Very important points in PMMC. Springs are carrying current. In PMMC, springs are carrying current. Okay, now? Then let's go for properties of spring material. Properties of spring material. First point, it should be conducting material. It should be conducting material and should not be a magnetic material and should not be a magnetic material. See why it should be a conducting material? Because springs should carry current into the coil. That is the purpose, and should not be a magnetic material. And it should not be get attracted by the magnets because permanent magnets are there beside it. Then next, it should be zero temperature coefficient. Should be zero temperature coefficient material. Next point is, so example for a zero temperature coefficient material. So they basically springs are made up of what? Phosphor, bronze alloy. Then next, PMMC works for DC. It is a polarized instrument. Plus comma minus are present. The next example, a single phase 110 volts, comma 50 hertz AC supply is given to 0 to 200 volts. PMMC instrument then meter. Option A, damages. B. No deflection. C. Pointer oscillates with respect to final value. D. 110 into root 2. Okay, now let's see what is the explanation. So why no deflection? Why no deflection? Simple example is for 50 Hz frequency. Explanation is for 50 Hz frequency, instantaneous currents reverses 50 times. Since TD directly proportional to I, then instantaneous torque reverses 50 times. Then the pointer has to do 50 oscillations mechanically, in 1 second. Practically, it is not possible. Due to damping torque. Practically, it is not possible due to damping torque. Inertia of moving system. Inertia of moving system, and insufficient time. Practically, pointer vibrates at zero position. Practically, pointer vibrates at a zero position. Implies no deflection. The next, if same input that is 50 Hz supply is given for long duration, coil will burn. The next, if single phase 110 volts, 2 hazards AC supply is given to PMMC, then pointer makes oscillations. Why? Since frequency is very low now, it makes oscillations. Two oscillations in 1 second is possible. 2 oscillations in 1 second is possible. With respect to zero position, but it is oscillatory output, difficult to take readings. The next, PMMC does not read AC. PMMC does not read AC since average torque is 0. Then next, final conclusion is PMMC works only for DC. Thanking you.